Okay, let's keep going. So before the break, we talk about one class activities. I give you any elements. You should be able to tell me all the information. We practice oxygen. Let's do another one. And in the test, I'll give you a similar one. This one is chloride. And you have proton number 17, atomic number 35.45. Which is 35? I'll in the test, I'll give you the atomic mass instead of atomic weight. So it won't be that confusing. And it's -1 charge. So the charge tell you, okay, every time you see charge, you know it's an ion. And it's -1. 1 is the only one you can choose not to write it. If it's 2, you have to put on, or 3. So negative means -1. So this guy, chloride, has -1 charge. So you know its proton number, which is 17, and electron number. This time they are different. They're different. Okay, so chloride 1735. What's number of proton? Number of proton is 17. It need to be 17 to be chloride. Number of neutron is atomic mass is 35. Atomic proton number is 17. So neutron number must be 35 minus 17 will be 18. That's number of neutron. Okay, number of electron. So this guy, proton number is 17. If it's neutron, electron number need to be 17. But it's not neutral because it's -1. -1 means one more negative than positive. So positive number is 17, negative number need to be 18. That's why it has -1. So number of electrons is 18. So far, so good. Okay, so every time you see ion, you know the proton number and electron number, they are different. So what's the atomic number? Atomic number is 17. Atomic mass is proton plus neutron. 17 plus 18 will be 35. Also, you can use the atomic weight to look at it. It will be very close to its atomic mass. So it's 35. Number of valence, okay, it has 18 electrons. So let's draw it together. You can draw it, use pen and paper, or draw it in your mind. It's 18 electrons. The first layer, 2, right? And the second layer, 8. 2 and 8, 10. So you have 8 left because totally you have 18. So all 8 you put into the third layer. Third layer, the outer layer, the electron there is valence electron. So number of valence electron will be 8. Name of this atom, chloride. Chemical symbol, Cl. So that's how we deal with ion, the one with charge. Okay, let's practice one more. Magnesium. And this guy has +2. So you know it's ion. He has 2 positive charge, means he has 2 more positive than negative. So he has 2 more proton than electron. Okay, let's look at this. For magnesium +2, magnesium ion. Number of proton, 12. It need to be 12 to be magnesium. Number of neutron, okay, his total atomic weight is 24.3, means its atomic mass will be 24. At least the main form of magnesium will be 24. You'll be very close to atomic mass. So it's 24. And 24, number of electron, use 24 minus 12, there will be 12. And number of electron, okay, if magnesium is neutral, its number of electron will be 12. But this time it's +2. +2, so he has 2 more positive than negative. And proton is 12, so electron must be 10. Must be 10. That's why he's +2. So number of electrons is positive is 10. Atomic number 12, atomic mass 24. Number of valence. He has 10 electrons. The first layer, 2. The second layer, 10 minus 2, 8. Number of valence electron will be 8. Name of this atom, magnesium, chemical symbol, Mg. Okay, so you find now you have a feeling that, okay, it's electrons, their number can increase, decrease. Yes. So electrons, I say, it give you the atoms his personality because they want to be stable, want to make the atom stable. So what make it stable? So those atoms, they can, especially the valence electrons, they want to be stable. And in chemistry, stable means you need to follow the 288 rule. Means it's valence electrons. The first layer need to be 2. The second layer need to be 8. The third layer need to be 8. And to make it stable, or say make it happy. Happy means stable. So those valence electrons, they need to be filled. So, and most of them, unless you are noble gas, your valence electron won't be filled. That's when they start to have chemical interaction with others. So they start to form bond. That's why I say the electrons, especially the valence electrons, decide their personality because they either share the electron or give the electron away or giving the electrons or gain the electrons, and they can form the bond. So we have 3 kind of bond we're going to talk about here. First one is called the ionic bond. And the second one is the covalent bond. And we have the polar and nonpolar. And the third one is called the hydrogen bond. So let's look at those 3. The first one is called the ionic bond. Definition: giving electron away or gain electron. 100% giving away or 100% gaining electron. So the result is ion. So we talk about, okay, the number of proton and number of electron when they're different, because proton has positive charge, electron has negative charge. And when their number are different, you start to create charged particle, we call them ion. And that's when that's when the ionic bond is formed. And say sodium has positive charge, right? Sodium ion has positive charge, and chloride has negative charge. And these different charge ions will attract each other. So that's when they start to form the ionic bond. Okay, so let's look at sodium chloride. Sodium, atomic number 11. So you know it has 11 proton, it has 11 electron. So the first layer, 2, second layer, 8, third layer, 1. And you need to be happy. Happy in chemistry, happy means low energy. So you need to find 7 more to fill this valence shell, which is very difficult. It's much easier for sodium to give this electron away. Now this shell disappear. And for sodium ion, its valence shell will be this layer. And its valence electron will be 8. Again, for sodium ion, sodium Na positive. So sodium love to give this electron away to follow the octet rule. Follow the octet rules, make it happy. Happy means low energy. Then let's look at the chloride. Chloride's atomic number 17. So it's 17 proton. It must have 17 electron. 17 electron. The first layer 2, second layer 8, 2 and 8 together 10. So the third layer 7. And for it to follow the octet rule, every atom want to follow the octet rule, which is the 288 rule, to make them happy. Happy means low energy. So for chloride, it's much easier to gain 1 electron. He has 7 already. To gain 1, he has 8. Instead of giving those 7 away. So for chloride, it loves to gain one more electron. And when you gain 1 more electrons, he has 1 more negative, because now he has 18 electrons, 17 protons. So here's one more negative, so become chloride negative, chloride negative. So you find sodium love to give electron away. It become positive one, it's a sodium ion. Chlorides like to gain one more electrons, become negative one, become chloride ion. And positive, negative, they attract each other. This kind of bond, ionic bond. It's a strong bond. So sodium chlorides, you put sodium, which is a metal, chloride, which is a gas, and you add heat. You just give them fire. And suddenly they turn into this called sodium chloride. Sodium chloride is the table salt, very stable molecule. And they are so happy together. And remember, I say in chemistry, happy means low energy. So they are very happy together. They are very stable. Sodium chloride is a very stable molecule. You use it to cook, right? You give them a lot of heat, they're still stable. Compared with those molecules create a firework, they are very, very unstable. You give them a little bit fire, they explode. So sodium chloride means very stable. So this is the ionic bond. First, you create ion, and then this kind of bond, they attract each other. And for the ions with positive charge, we call the cation. So cation is the ion with positive charge. And if the ions have negative charge, we call the anion. Anion, like chloride is the anion. Sodium is the cation. So cation and anion attract each other. That's the ionic bond. Okay, so for example, CaCl2, calcium chloride. And calcium, okay, is what proton number is 20. So 20 positive charge proton, it must have 20 electron. 20 electron, the first layer 2, the second layer 8, the third layer 8, so totally 18, right? And 2 more outside calcium. And it's much easier to give those 2 electrons away than gaining 6 electrons. So calcium love to give these 2 electrons away. And when the calcium give those 2 electrons away, they become calcium ion, which has positive 2. So because it has 2 more proton than electron. And then chloride, we just talked about chloride. Chloride, each one's, they want to gain 1 more electron. So chloride will gain those electrons. It's 1 more negative, become chloride ion. So each chloride can only take 1 electron to follow the octet rule. So 1 calcium have to pair with 2 chlorides. So CaCl2 is a salt. They use the ionic bond to connect to each other.